Hello students, welcome back to Programming in C language. Myself Sreekanth. Yes, in the previous session we discussed in detail about types of computers like digital computers, analog computers and hybrid computers. In digital computers again we discussed size wise and purpose wise and function wise. Okay, today I would like to complete these types of computers with the in detail description about digital, analog and a hybrid. Means digital only we discussed in detail in the previous session. Okay, in this session we try to discuss in detail about what analog computers and a hybrid computers. Okay, yes, the agenda of this session: types of computers, digital computers, analog computers, hybrid computers, and difference between digital, analog, hybrid, some components, advantages and disadvantages with the suitable examples. Okay, see, if you missed the previous session regarding digital computers with the purpose wise, size wise, function wise, yeah, I provided link in the below description. Just go through that video. After that you need to understand the remaining analog and hybrid computers in this session. Okay, yeah. So this is what we discussed in the previous session about types of computers like a digital, analog, hybrid. In the purpose wise, general purpose computers, special purpose computers. Coming to size wise, microcomputers, mini computers, programmable computers, laptop, desktop or personal computers, mainframe computer, supercomputers. And coming to function wise, server, what is client and server model, explained clearly in the previous videos about workstations, embedded computers, information appliances. See, in the previous 2 or 3 videos, I explained in detail about all these purpose wise, size wise, function wise of digital computers. Just go through that videos. Okay, fine. Yeah, just I am brush up the things what we discussed in the previous session about digital computers. Say digital computers are the computers that works on what discontinuous data or discrete data. Always it going to be represented by what zeros and ones. We can also call it as binary language or machine understandable language, because in digital computers all the data is going to be represented in the form of what binary only, zeros and ones representation. Okay, I already explained in clearly about memory representations like 2 to the power of x equals to y. Okay, you can also go through that video. You may understood clearly how the memory is going to be represented in the form of bits, bytes, kilobytes, megabytes, gigabytes, terabytes, petabyte, hexabytes, zettabyte and yottabytes. Okay, see, coming to digital computers, it understands only binary language represented by what? Zeros and ones representation. See, these computers basically work by what? Counting and adding the binary digits. Data flow in the form of what? Clock pulses. See, I clearly explained, right? How the data is going to be flow in the form of what? Clock pulses in this manner. So it is represented by what? 1 0 0 1 on off, like that it going to be represents. So this is about what? Clock pulses we may call it. See, these more accurate, faster and reliable. Digital computers are what? More accurate, faster and reliable. It is designed to perform calculations and logical operations at a high speed. It accepts the raw data as a input. Say, I told you very clearly about data, right? It takes data. It may be a numbers, digits, symbols, images, audio, video, any kind of instruction we are passing through the input. See, that comes under what? Raw data with the programs, and it stores into what? Memory. After processing it, it generates what? Output or information. See, all modern computers like microcomputers, mini computers, laptops, desktop computers, see, these are all used for what? These are all belonging to what? Digital computers only. So this is what I clearly explained about digital computers, size wise, purpose wise and function wise. See, coming to some advantages of digital computers, it allows you to store a large amount of information and to retrieve it easily whenever you need it. See, as we discussed in the data measurement units, it's going to be store huge volume of data. See, nowadays we are going to be using very frequently up to terabytes, like kilobytes, megabytes, gigabytes, terabytes we are going to be using, correct? you can easily add some new features to digital systems more easily. So we can easily add some new advanced features on it. Different applications can be used in digital systems just by changing the program without making any changes in the hardware. As I told, we can develop several applications belonging to the real-time environment like CUI based applications, character user interface applications, GUI based applications, graphical user interface applications like desktop applications, notepad, okay, wordpad, MS office related application, adobe, and mp3 players, audio video players, okay, like network based applications. And we can also develop what internet based applications, we can also call web applications, and huge uh, request response between client and server applications like enterprise applications. Like that we can able to develop mobile application, like various applications we can develop using what digital computers. The cost of hardware is less due to the advancement in the IC technologies. It offers high speed as the data is processing digitally. It is highly reliable as it uses error correction codes. See, nowadays whatever we are using, these are all belonging to our digital computers only. Okay, we can also develop using some programming, we can develop some applications used within the digital computers only. So these are all the advantages of what digital computers. And coming to analog computers. See, analog computers is a type of computer that uses the continuously changeable aspect of what? Physical phenomena such as electrical, mechanical, hydraulic quantities to model the problem being solved. As we discussed in the previous slides about digital computer, it works what? Discontinuous data, discrete data represented by zeros and ones. But coming to analog computers, here how the data is going to be work continuously. Generally it is used to measure the physical quantities like pressure, temperature, speed, and so on. These computers accepts input data in the form of signals and convert them into what? Numerical values. Okay, best examples like audio video transmissions, thermometers, speedometers. These are all the various examples of what? Analog computers. Mainly it is used for what? Scientific and engineering purpose. These are designed to process the analog data. Analog data is what? Continuous data that changes continuously and cannot have discrete values such as speed, temperature, pressure, and current. Okay, the analog computers measures the continuous changes in what? Physical quantity and general render output as a reading on a dial or scale. Analog computers directly accept the data from the measuring device without first converting it into what? Numbers and codes. See, as we discussed in digital computers, whatever the data we are going to be given, that going to be convert what? High level instructions into what? Machine understandable instructions. Here directly that instruction is going to be taken from what? Directly devices. Speedometer and mercury thermometers are examples of what? Analog computers. See, analog computers are used to what? Process analog data. Analog computers directly accept the data from the measuring devices without first converting it into what? Numbers and codes. They measure the continuous changes in what? Physical quantity and general render output as reading on a dial or scale. Speedometer and mercury thermometer are examples of what? Analog computers. Best example you can take EAI TR10 desktop analog computers. See, electronic associated ions increment. Okay, say anti-criteria mechanism, hit kit, EC1 educational analog computers, polish analog computers, switching board of EA 8800 analog computers, William Ferrell's tide predicting machine of 1881-2 EAI 8800 X15 simulator analog computers. These are all what best examples of what? Analog computers. Just you need to remember, analog computers are used to measure what? Physical quantities. It going to be works on what? Continuous data like pressure, temperature, speed, and so on. Okay, this is about what? Analog computers. Several advantages of using analog computers: it allows real-time operations and computations at the same time and continuous representation of all data with the range of the analog machines. In some applications, it allows performing calculations without taking the help of what? Transducers for converting the inputs or outputs to digital electronic form and vice versa. The programmer can scale the problem for the dynamic range of the analog computer. It provides insight into the problem and help understand the errors and their effects. Okay. See, as we discussed in the analog computers, these are all the advantages. Okay, we can also use it for analog computers for what? Mechanical analog computers, electronic analog computers. See, coming to electronic analog, like mathematical operations like addition, integration, inversions, multiplications, exponentials, logarithms, divisions, and so on. Several components and also there we'll discuss now. Okay. Yeah. See, these are all called different types of analog computers like slide rules, differential analyzers, Castle clock, electronic analog computers, mechanical analog computers, pneumatic analog computers, hydraulic analog computers. See, coming to slide rules, see, it is clearly telling about what? It is one of the simplest type of what? Mechanical analog computers. It produces approximate result for simple mathematical operations. So this, using the slide rules, we can able to calculate what? Simple mathematical operations. Okay. See, the main intention for developing these slide rules, basic mathematical calculations. Okay. See, they used like two rods to perform the calculation. The hashed rod is slid to line up with the marking on another rod, like that. Okay. See, the second type of analog is what? Differential analyzer. It was developed to perform what? Differential calculations, designed to solve for all different differential equations. It performs integration using wheel and disc mechanism to solve differential calculations. See, using this differential analyzer, we can able to calculate differential calculations. Castle clock, it was invented by Zarzi. It was able to save programming instructions. It's going to be say what? Programming instructions. This computer was able to store what? Different programming commands. The example they given it, right, for calculating what as per the current sessions. Okay. These devices also could allow user to set the length of the day as per the current sessions. Next, electronic analog computers. So initially they were used in the different missiles, airplane, layout and flight simulators. Electrical signals flow through what? Capacitors and resistors to simulate physical phenomena. So the main intention for using this electronic analog computers for what? See, this data, the signals are going to be flow through what? Capacitors and resistors to simulate physical phenomena for simulations. Okay, for these analog electronic analog computers are going to be introduced. Yeah. See, another some types also there: mechanical, pneumatic and hydraulic. Yes, coming to mechanical analog computers, observe here, these computers are designed along with what? Different components such as gears, lever. See, lever is nothing but what? Simple machine consisting of a beam or rigid rod pivoted at a fixed hinge, in which not use electronic parts. It produces output while turning off gears, and it can perform multiplication and division operations like cosmic engine, Pascaline, stepped reckoner. These are all the what examples of what? These mechanical analog computers. See, pneumatic analog computer, these computers use the compressed air, okay, in the form of what? Power source. That is very simple and inherently analog. These computers mostly used in what? Non-residential building areas. And last one, hydraulic analog computers. Hydraulic analog computers was developed by what? Mihailo Petrovic Alas in 1868, 1943. Main objective of designing of this computer is to solve the differential equations. See, these are all what? Various different types of what? Analog computers. Okay. See, the digital computers, various digital computers we discussed about microcomputers, mini computers, programmable computers, laptop, desktop, mainframe, supercomputers. These are all what? Examples of our digital computers. But coming to analog, these are all called various types like slide rules, differential analyzers, Castle clock, electronic analog computers, mechanical analog computers, pneumatic analog computers, hydraulic analog computers. These are all what? Different types of analog computers. Some components of analog and examples are also, you can check it out here, like resistors and capacitors, operational amplifiers, multipliers, potentiometers, fixed function generators. These are all what various components of analog computers. You can go with examples like hybrid controllers, mainly used for what simulations like vehicle, moon landing, aircrafts, and so on. Like mass spring damper systems, thermometers, speedometer, telephone lines, resistance of capacitors, frequency of signal and voltage, televisions, mechanical integrators, electrical integrators, and so on. These are all what various examples of what analog computers. Okay, the last one about what hybrid computers. See, as we discussed previously about these hybrid computers in detail, hybrid computer, it is a combination of what both digital and analog computers. Okay, it is useful in where both digital and analog signals are used in what processing. It is fast like analog computer and has memory and accuracy like digital computers. It can process both continuous and discrete data. See, continuous means analog computers. Discrete means what? Discrete. Discrete or discontinuous data means what? Digital computers. This both combination is called hybrid computers. It can process both continuous and discrete data. So it's widely used in what specialized applications where both analog and digital data is processed. Best example like petrol pumps that converts the measurement of fuel flow into what quantity and price. This is the best example. Okay, and a hybrid computer should be distinguished from hybrid systems. Later, maybe no more than a digital computers equipped with what analog to digital converter at the input and or a digital to analog converter at the output to convert analog signals for what ordinary digital signal processing and conversely. Example like for driving physical control systems such as servo mechanisms. Okay, so here required for what conversions like analog to digital converters, digital to analog converter at the input and output. Polish hybrid computers like VAT 1001, HiCom 250. See, these are all what examples of what these hybrid computers. Okay. See, about EA 8812 analog computers, EA 8100. These digital computers. Later, it's going to be converted SCL 3200 digital computer. Digital signal processors. Best examples used these hybrid computers, airplanes, hospitals, and scientific related applications. See, these are all what about hybrid computers, but you need to remember the point here. Hybrid computer is a combination of what both digital and analog signals for use at what processing. Okay, both digital and analog. Digital means what discontinuous data or discrete data. Analog means what continuous data. Okay, so these 2 points you need to remember very clearly about what hybrid computers. Okay, yeah. See, several advantages of using hybrid computers. Its computing speed is very high due to the all parallel configuration of the analog subsystems. It produces what? The precise and quick results that are more accurate and useful. It has the ability to solve and manage big equations in what? Real time. It helps in the online data processing. Okay. So where it required for both analog continuous data performance and discontinuous discrete data performance, that time we go with what hybrid computers. Okay, this is about what combination of both analog and digital computers. Okay, yeah, today we discussed in detail about what different types of computers, especially digital computers. Okay, I explained very clearly about the previous videos about each purpose wise, size wise, and function wise. Okay, if you missed that session, I given in the description link. Just go through that session in detail about digital computers. And today we discussed in detail about what analog computers, hybrid computers. Analog computers, again several examples, components, and some applications. Hybrid computers with advantages. Okay, so this is about the today's session. I clearly explained about what the different types of computers with the components, applications, and advantage. Okay, so if you like these videos, make it more like, share, and more subscribe these videos. Okay, thank you all. Thank you.